Okay, students, this is your well-rounded math teacher again, Mr. Picard. And we're going to be talking about exponential growth and decay. But more importantly, more specifically, the exponential growth and decay formulas that arrive from exponential equations. Okay, which we use on certain assets like homes, can appreciate or increase in value over time. Unlike cars who depreciate or decrease in value at times. We've done some formulas like this, but I'm going to show you a specific formula that works pretty well. Suppose you buy a car for $22,000 and the value of that car decreases by 16% per year, which is about right. It makes sense. Write an exponential function of the form y equals ab to the x that could be used to model the price y of the car. Write a function in terms of x, and here we go. So it starts with this, y equals ab to the x. Y is value going to be value after x years, whatever it is. A is your initial amount, and that's $22,000. That's pretty cheap for a new car nowadays. And b, well, it's 16% that it's going to come off the car every year. So this is definitely decay. But if it didn't decay or it didn't grow, right here, your b would be 1. So what we really have to do is take 1 or 100% and subtract 16% from it, because it decays 16% every year, but what does it actually retain? It retains 84%. So what we're going to do, instead of plugging 1 in there, we're going to plug in 0.84. If it goes down 16% every year, it retains 84%, or 0.84 to the x power. And this is the formula you would use to find the value of a car after so many years. Here we want to find the car 2, 3, even 7 years later. So let's just plug in 7. 22,000 times 0.84 to the 7th power. Plugging in 7 years, if you plug this into your calculator, you should get $6,491.99. So basically, you're going to want to get rid of your car before the end of 7 years, but it's going to be worth about $6,500. Okay, and this is basically what we're going to be doing all day today. Anyway, exponential decay. When a quantity decreases by a fixed percent every year, over a period of time, the amount of the quantity t years is given by this. Now, this is no different than y equals ab to the x, except x is now t. It's my time. That's what it's been for a long time. A is still your initial amount. This 1 minus r is your b. If you didn't have the r at all, it would be 1. It wouldn't change in price at all. It would stay that original amount. But being you're subtracting r, that's the decay, the percentage of decay every year. It's going to be how much value you retain on the car per year. So this is our decay formula. It's no different than this formula. It's a little bit more specific for you. Maybe it's a little bit easier to use too. A cup of coffee contains 130 milligrams of caffeine. If caffeine is eliminated from the body at a rate of 11% per hour, how long will it take for half of the caffeine to be eliminated? So what we're saying is, how long does it take to go from 130 milligrams of caffeine to half of 130 is 65 milligrams. So this is my A right here. That's what I start out with, my original amount. This is going to be my Y. That's what I want to have left. I want to have 65 milligrams of caffeine. I got about 250 in me right now. No big deal. So using our formula, Y equals A times 1 minus R. There's our decay, if you will, to the t power. What we're really going to be looking for is t in this case, because I know y is 65. I know a is 130. That's the original amount. And then I got 1 minus 11%, so it's 0.11 is going to be to the t power. So the only variable I have left is t, so I got to solve for t. So I got to do a little bit of cleaning up, and then we're going to have to use common logs in order to solve this. So 65 equals 130. 1 minus 0.11 is going to give me 0.89 to the t power. So I'm going to get this 0.89 to the t power by itself. I'm going to divide both sides by 130 because you're multiplying by 130 over on this side. These cancel out. 65 over 130 is obviously 0.5 because it's half of 130. Half the caffeine equals 0.89 to the t power. They don't have the same base. This is 0.5 and this is 0.89. So I'm going to have to use the common log here. I'm going to take the common log of 0.5 equaling the common log of 0.89 to the t power, which means I can take this t and put it in front of my common log and multiply it. So I have the common log of 0.5 equaling t times the common log of 0.89. Now, if I want to solve for t, I got to get rid of this common log of 0.0 or 0.89. Okay, so I got to divide both sides by the common log of 0.89. And that'll give me my answer, t, because these are going to cancel out now. The easiest way to do this is put it in parentheses. Take the common log of 0.5 in parentheses, and then divide it by, in parentheses, the common log of 0.89. You should get 5.95 hours. So basically 6 hours it takes for this caffeine to go from 130 milligrams down to half, which is 65 milligrams. And that's kind of what we're working with today, children. Let's go back here for a minute. Okay, we're still on exponential decay. The store is offering a clearance sale on a certain type of digital camera. The original price of the camera was $189. The price decreases 10% each week until the cameras are sold. How many weeks will it take for the price of the cameras to drop below half of its original price again? So basically we're going from $198 to half of that, which is $99. Using this formula up here again, our final amount we want to be half of 198. So that's going to be 99, and that's my y up here, equals my original amount or initial amount, 198, times 1 minus, in this case, 10% is 0.10 to the t power. So once again, I'm solving for t. So it's just like the last one. I want you guys to try this now. If you make a mistake, that's fine. Just hit pause right now and then go ahead and figure this out. So I'm going to give you a chance to hit pause. And we're back again. Good job. Let's see what you got. See if you get the same thing I do. So this is 99 equals 198 times this would be 0.90 to the t power. I want to get that 0.9 to the t power by itself. So divide both sides by 198. I'm going to get 0.5 equals 0.90 t, or just 0.9 t, it doesn't matter. And in order to solve this, they don't have the same base again. I got 0.5 and 0.9, they're not the same. So I got to use common log. So I'm going to take the common log of 0.5 equals the common log of 0.9 to the t power. Now, I have a log and I have an exponent in my expression, so I can bring that out over here and multiply it. So I have the common log of 0.5 equals t times common log of 0.9. To get t by itself here, you're multiplying, so the inverse operation would be to divide by the common log of 0.9. Okay, so t equals, remember, put these in parentheses. the whole thing and divide it. And you should come out with cameras, half price. I get 6.58. So basically about 6.5 weeks to get the price of those cameras down. And we will finish these notes tomorrow, working with growth and a little bit of exponential growth and decay used by scientists. That'll be fun. Scientists are cool people. Peace.